Hello everyone. In this video I want to show you how you can do a quick flood analysis for a potential dam site. So we are going to need to have a digital terrain model of the area already, and what we're going to do next is to specify where the embankment of the dam is going to go, and then based on that we are going to create our flood analysis. For this exercise, you can use the same digital terrain model we use for these exercises. So this will be in your rasters Geo package from the project files. So just expand that and grab the DTM and drag it into the viewport. Now the very first thing we're going to do is to export this DTM out because we don't want to edit the original. So we're going to make a copy of this, and we can right click on the layer, go to export, save as. We're gonna leave this at raw data and geotiff, so everything will stay the same. We're just gonna click on the ellipsis button and save this out somewhere to our hard drive. Click on save, leave the add save file to map box ticked on and press OK. Now we can delete the original DTM, we are not gonna need that anymore. And as usual, when we do this kind of hydrological analysis, oftentimes we may want to just make sure that there are no artificial sinks in a digital terrain model. So we are going to do a fill sink. So in the bottom left corner in the search field, type fill sink, and we're going to use the fill sinks by Wang and Lu. And you can just run this on the default settings. The only thing that we need here is the fill DEM. So I'm going to turn off the other two outputs and just leave the first one on. So our field DEM layer was now computed. We can exit out of this panel, and we don't need the original DTM we created anymore, so we can just delete that one. And I'm gonna rename this DEM. The next step now is to specify where our embankment is going to go. And to make this easier, it may be a good idea to extract a contour map from the DEM first. So we're gonna select it, go to raster, extraction and contour. And for this exercise, I'm going to do a small interval between contours, so just 10 meters is going to be enough just to quickly inform me where I want to place the dam potentially. But obviously on a real project, you have to be a lot more careful, and you may have to use a much higher density contour map when you're placing your embankment. But for now, I'm going to leave this at 10 meters and click on run. And I'm going to close out of this panel. So I think for a good spot maybe for a dam would be one of the major valleys, maybe a secondary valley like what we have here in this corner. Strictly for visualization purposes, obviously on a real project, a dam is most likely not going to go into this kind of a steep valley. Of course, we can also do it anywhere else, but just for the sake of visualizations, I'm going to do it in this valley right here. And it's going to be a rather extreme example, just again for visualization purposes. Obviously, we're not going to make any kind of huge dam like this for the most part these days. But I'm going to do a rather massive embankment just to drive the point home of how this analysis can work. So we are going to need to create a new vector layer. We're going to come here to the new shapefile layer button and click on that. And for this, we're going to use a polygon, and this will basically contain the outline of our embankment, or just the crest of the embankment. So we are going to set the geometry type to polygon and make sure to set the project's coordinate system to be the same one as that of the project, which is this one. And it's the same one that our DEM is using. Now, under the new field area here, we're going to type the name crest, or it can be elevation or whatever you want. This will be the elevation of our crest, basically. The type, we're going to set this to whole number and click on add to field list. And then we're going to press OK. So this created the new embankment layer, which is currently empty. Now we're going to click on the edit button here to toggle the edits for this layer. And now we just need to quickly sketch out the alignment of our embankment. It doesn't have to be precise in terms of the width, but it needs to be precise in terms of the elevation that we want the embankment to sit on. And so we can get an idea of the elevation by just grabbing the contours or the digital elevation model and clicking on the Identify Features tool. And let's say we want our embankment to stretch across this entire area here, starting from around this point right here. So if I left click there, you can see the band value is going to change depending on where I'm clicking with my cursor. So maybe we do an embankment that stretches from elevation 600 all across to the other side to elevation 601, assuming we want a 1 meter freeboard, which is a bit crazy on this kind of valley. But in any case, we can grab now contour 600. So again, just using the select features tool, just grab the one that has elevation 600, which is right around this one right here. So that would be this one. So I'm just going to highlight it like that. And you may also want to grab the select features by area tool right here and just grab that contour. I think it was this one, I believe. Yeah, this is the correct one. So we're just going to highlight it like that to see it visually where it is. And then we're going to go to our embankment layer, select that, and it already has the editing toggled on. So we are going to come up here to add polygon feature and click on that. And then you just use either the snapping tools that are right here under the project snapping options. You can set this magnet icon on, and then you can choose either from vertex or vertex and segment or segment. Any one of these will work, and this will allow you to snap to the contour line. And then I'm going to extend the line, maybe crossing this way onto the other side, and I'm actually gonna do just 600 to 600 because these are 10-meter contours, so we can't do 601 easily right now. But it doesn't matter for the purposes of the exercise. I'm gonna do 600 on both sides and maybe do a little bit of a wider polygon just so we can see it. Again, the width doesn't matter. You don't have to be precise about that right now. Then I'm going to right click, and this will now prompt me to specify the elevation under the crest attribute we created earlier. So I'm going to call this 600 and press OK. If you want to, for some reason, modify this line, you can always come back here to vertex tool and then just grab one of the vertices and you can modify it. Okay, so for the most part, this is ready. Now we can exit out of these panels, select the embankment layer, click on the toggle editing button to save the changes. And the next thing that we are going to do is to integrate this embankment that we sketched out into our digital elevation model. So we want it to become part of that digital elevation model so that when we run the flood analysis, the algorithm is going to detect there's a barrier here embedded in the digital elevation model. And so it's going to impound any water that is being simulated. And to do this, we're going to use an algorithm called rasterize. So we're going to go back to the bottom left corner in QGIS and type in rasterize. And we want the one called override with fixed value. It can also be override with attribute. Either one of these will work. So choose whichever one you like. This one is a little bit easier to use because you don't have to select an attribute. Now, in the input vector layer, we're going to select our embankment layer. In the input raster layer, we're going to select the DTM. And the fixed value to burn is going to be the elevation that we specified for our crest, which, if you remember, was 600 meters. So we're going to add that there and click on run. And that's about it. So we can exit out of this algorithm. And now if I disable the contours and the embankment, you should see that the embankment was integrated into the digital elevation model. So it basically added this 600-meter elevation barrier here. And this is actually a pretty big barrier because if we look at the elevation of the DTM here in the darker area, it's 395, and then all of a sudden we have a 6-meter barrier. So that's around a 200-meter difference. But again, this was for the sake of visualization purposes. So the next step is to run the flood analysis, and we're going to specify a point of elevation at which the flood waters are going to come in, and exactly where that point is going to be. So that's where basically the algorithm is going to start running the simulation from. So I want to select a point somewhere in this valley, and maybe we place it, let's say, 5 meters below the elevation of our crest. So to do the flood analysis, we're going to type in the bottom left corner again a command called lake, and we want this one r.lake. So you're going to need the grass extension for QGIS. Double click on that, and then for the elevation we're going to select our modified DTM now. The water level will be 5 meters below our crest, so that will be 595. And now we need to specify the point of the flood origin. So you can either create a point layer already and just select that point if you want it to be a very specific point, or you can just click on the ellipsis button here and directly specify the location of that point in the viewport. So I'm just going to randomly click somewhere in this valley here, and you can see the coordinates will be specified there. We're not going to specify anything under raster layer with starting point. So if you, this is for cases where the point is actually a raster and you want to specify that instead of a vector point or a coordinate. So you can do either one of these, but in this case we just specified it directly onto the DTM there. And that's it. Now we can just click on run. And you can see that a new layer was created called lake. I'm just going to rename this to flood. You can see how it detected the barrier that we put in here, because the water simply couldn't go around it in this particular case. Maybe if we raise the flood level a little bit more, it will actually go into this valley here, and maybe even go on the other side if we specify an elevation higher than the crest. Now we can maybe stylize this a little bit more to give a little bit more of a visual information of what's happening. So let's turn off the contours and maybe also bring a satellite map in the background. So we are going to need the Quick Map Services plugin. If you don't have that, go under Manage and Install Plugins and type Quick Map in the search and select Quick Map Services and install it. And then you're going to find it under the web menu, Quick Map Services. And then you can go under Search QMS. In the search string here, type Google Satellite and maybe select this one and click on Add. We are going to turn off our digital terrain model for now and just have the flood water and the Google Satellite map showing here. So we're going to expand the flood water layer, and we can see we have elevation from 0 to 190. And actually this is a little bit counterintuitive because it gives us positive elevations, and we actually want negative elevations because this is if we count it from the top of our flood water. So maybe that's a little bit more intuitive to read for other people. So we're going to come back under r.lake and again specify 595 for the elevation. And let's do again some seed point right there. And you can see there's a command here to use negative depth values for the lake raster layer. So this is basically going to set these values to negative and invert them. So let's do that again and set the DTM here for elevation and click on run. And we can delete our original layer with the positive values now. And now you can see how it got inverted. And if we expand it now, it's in negative values. So actually the total depth of this lake here is 190 meters at this point. So it's pretty crazy. But in any case, we can go under the properties of this and symbology, and we can change this from render type of single band gray to single band pseudo color. And you can do maybe discrete elevations if you want the levels to be very discretely delineated instead of this smooth transition. And you can maybe try it like that. See if you're happy with just having these few values here. I think it's just 5 values or a little bit more than that. But you can call out more values if you want. And if you want the label precision to be more simple to read, you can reduce this to 0 under label precision and click on apply. If for some reason your color ramp looks different, then just come in here and select blues, and then you can invert it if it's not showing correctly. I like the darker color to be at the bottom, obviously. Now, if you want to change the number of values you can call out here, you can either create your own values by adding them manually, or you can switch the mode to one of the other ones and then just increase the number of classes, and that will give you a higher number of values here. Now this layer can be exported, so if you want to bring it into Google Earth, for example, you can just export this out just by right-clicking, going to export, save as, and we can export this as a rendered image in this case, because in terms of Google Earth, we don't necessarily need this data to be embedded in the layer. We can export it later as a legend and attach it to the image. So we're going to go on the rendered image, untoggle add save file to map and click on the ellipsis button. And I'm going to save it somewhere on my desktop to flood as a flood a file name and click on save, and then press OK. And while I'm here, I'm also going to bring in a screenshot snapping tool. So in Windows, there is this snipping tool that comes by default. And I'm gonna grab a new screenshot of the legend here. And before I do that, let me just deselect anything on the legend. And I'm going to save this out as well. Now we can open up Google Earth, and we just need to drag and drop our flood into Google Earth. And when it asks us what to choose here, just click on scale, and I'll rename this to flood and delete anything in the description and press OK. Now to bring in our legend, we are going to click here on add image overlay and click on browse. Go to the location where the legend is and just double click on it to select it. And I'll rename this to legend, or maybe flood legend. And now hold the shift button and left click on one of the corners of the image and drag it to scale it uniformly and place it somewhere next to the map where it's going to be visible. You can also reduce the transparency of the flood map if you want to see some of the underlying satellite image. Another thing that may be useful in these cases is to bring out also a hillshade map, which I've done videos on how you can do that, but very quickly we select the DTM, go to raster, analysis and hillshade, and run everything with the default settings. And because this will bring out the embankment more visibly. And then this is a nice layer to have underneath the flood map layer, and you can also export that out to Google Earth. So this is how you quickly create a flood analysis for an embankment. We are going to cover other forms of flood analysis later in future videos, but for now I hope this was useful and interesting, and we'll see you in the next session. Thanks for watching.